Of all the front-end frameworks and libraries that existed in 2015 and 2016, why did React become the go-to choice for universal JavaScript? Not because it was the most popular, Angular had a head start. Not because it was the most full-featured, Ember had routing, state management, and conventions out of the box. React won the universal JavaScript battle for one very specific reason: its rendering model is decoupled from the DOM. Think about what most UI frameworks do. They build components that directly manipulate DOM nodes. They bind events to DOM elements. Their entire runtime is built around the assumption that a browser's document object exists. Port that to a server and you immediately hit a wall. Node.js has no DOM. React made a different choice. A React component describes what the UI should look like, but doesn't directly create DOM nodes. Instead, it creates a plain JavaScript object, a virtual DOM node, that says, I want a div with these properties, containing these children. The actual rendering step, converting that virtual DOM to real DOM nodes, happens in a separate library, React DOM. And here's the insight that makes universal JavaScript possible: if rendering is a separate step, you can swap out the renderer. In the browser, React DOM renders virtual DOM to actual DOM nodes. On the server, React DOM server renders the same virtual DOM to an HTML string. Same components, same component logic, completely different output format. This is why the book focuses on React as the vehicle for universal JavaScript. It's not because React is the only option. Vue and Angular have SSR solutions too. It's because React's architecture makes the separation between describe UI and render UI explicit and clean. That separation is the foundation of server-side rendering. To understand React at the architectural level, you need to start below JSX. Before JSX exists, before Babel runs, there's a single function, React.createElement. React.createElement takes three arguments: a type, a props object, and any number of children. The type can be a string like div or h1, those are HTML elements. Or it can be a function or class, those are your custom components. Props is a plain object with key-value pairs that become attributes or passed values. Children are more React elements, or strings. What does React.createElement return? A plain JavaScript object. Not a DOM node. Just an object with a type field, a props field, and a children field. This is a React element. It's just data describing what you want. Now, writing React.createElement for every element in a complex UI is tedious. A single page might have hundreds of elements. That's why JSX was invented. It's a syntax extension for JavaScript that lets you write HTML-like syntax, and Babel transforms it into React.createElement calls. When you write angle bracket syntax in a JSX file, you're writing shorthand for function calls. Their equivalent, JSX, is 100% syntactic sugar. Why does this matter? Because React elements are just plain JavaScript objects. You can create them, pass them around, return them from functions, put them in arrays. They're not special DOM types, they're data. And data can be serialized, compared, and manipulated. That's why React's diffing algorithm can efficiently determine what changed between two renders. It's just comparing JavaScript objects. Components are functions or classes that receive props and return a React element tree. This is all React is at its core: functions that take data and return element descriptions. Simple concept, profound implications. Describing static UI is straightforward. A React component returns the same elements every time. But real applications have state, a dropdown that's open or closed, a counter that increments, a form with user input. React's state model is what connects user interactions to UI updates. The original state API used class components. You'd extend React component, initialize state in the constructor with this .state equals, and call this .setState to update it. Calling setState has two important behaviors: it merges your update into the existing state object, and it schedules a re-render. React batches these re-renders for efficiency. Multiple setState calls in the same event handler produce a single re-render. Class components worked, but they had friction. The this keyword was confusing. Logic related to the same concern was split across lifecycle methods: component did mount, component did update, component will unmount. Sharing stateful logic between components required wrapper patterns like higher-order components or render props, which created deeply nested component trees. React 16.8, released in February 2019, introduced hooks, and they fundamentally changed how React components are written. The useState hook replaces classState with a simple function call that returns a value and a setter. The useEffect hook replaces lifecycle methods with a single concept: run this function after render, optionally cleaning up when the component is removed or dependencies change. Hooks let you write all components as plain functions. No classes. No this. No lifecycle split. Logic that belongs together stays together. And crucially for universal JavaScript, functional components with hooks are plain functions. They're easy to call on the server, easy to test in isolation, easy to reason about. The stateful model is also the key to understanding hydration on the server, which is exactly where we're headed next. Let's connect everything together with the concept that makes React genuinely powerful for universal JavaScript, the virtual DOM and its two rendering targets. In the browser, React maintains an in-memory copy of your UI called the virtual DOM. When state or props change, React builds a new virtual DOM tree representing what the UI should look like after the change. Then it runs a diffing algorithm, comparing the old virtual DOM tree to the new one, and finds the minimum set of actual DOM operations needed to update the screen. This is reconciliation. It's why React can update a complex UI efficiently. It doesn't re-render everything, only what changed. But on the server, there is no DOM. There's no browser, no document object, no actual DOM to update. So what does React do? React DOM server.render_to_string takes your React component tree, renders it running all the component functions, resolving all the JSX, and produces a plain HTML string. That string gets sent to the browser as the response body. The browser receives that HTML and displays it immediately, no waiting for JavaScript to execute. Users see content fast. Search engine crawlers see real content. This is the key benefit of server-side rendering: faster perceived load time and better SEO. But then the browser downloads and executes your JavaScript bundle. React loads, finds the server-rendered HTML in the DOM, and hydrates it, attaches event listeners, initializes component state, starts managing the DOM normally. The app is now a fully interactive single-page application. The user never saw a blank page. This two-phase render, server produces HTML string, client hydrates to interactive SPA, is the complete picture of server-side rendering with React. Understanding it at this level is the prerequisite for building the full universal application in the next section.